Okay, Sph4c. Let's talk about the examples of solving vector equations where we don't actually get a perfect triangle from the first time that we draw it. So let's take a look at this example here where I have vectors A plus vector B plus vector C. When I add them together, the displacement is from the initial position here to the final position there. But as you can see, we don't really get a triangle out of this. But there's a way that we can actually force a triangle out of it. So if you look carefully, and this is why we do these things using graph paper, is that you'll actually be able to create a right-angled triangle based on the grid along the x-axis and along the y-axis. So let me show you what I mean by that. So I'm going to highlight it in blue. So here is the x part of my triangle, and this represents the y part. So when you look at this, I now have a right-angled triangle here. So this whole length here along the bottom is actually the combination of side A and C combined. But on the vertical here, that's just actually equal to our B. So I'm going to call the this side on my new triangle, I'm going to call this Y. And on the x-axis, I will appropriately call it X. So there's two ways that we can actually figure out how much X and Y are respectively. The easiest way, of course, is just to count the squares. But there is a faster way where we can just do it mathematically. If you take a look, really, all X is A and C combined. And in the case of Y, Y is just equal to whatever B is. So when we take a look at vector A is 11 squares along the x-axis. Vector C has a magnitude of 6. So if we want to calculate X, that's just equal to A plus our C value. So that's going to be positive 11. And the reason why it's positive is because it's going to the right, plus positive 6. And that gives us a grand total of positive 17, whatever the units are. So let's say for the sake of argument, they were centimeters. So our X in this case would be 17 centimeters. And let's say going to the east, or it could be right. It depends on the way the question was originally worded. And then for the Y component, or the Y side of our new triangle, that is just equal to whatever B is. So whatever B was, whatever amount it was, is going to be the same as Y. So in this case, Y is equal to 8 centimeters north because of the direction that B was. So we can actually put a little arrow there and a little arrow there. And now we can see it. So now when it comes time to figuring out the magnitude of D, we just focus on the new right-angled triangle. And to clarify that, I'll just draw a new diagram so it's a little bit easier to see. So I'll just copy over the new stuff. So this was our displacement. This is our new total along the x-axis, our x vector, and there's our y. So when it comes time to solving it, you now have a simple right-angled triangle to work with. And that's it.